So it's time for our last tutorial for Chapter 6. We're going to be working on 6.2 number 37, which I happen to have right here. Let's see, Clarinex D is a medication whose purpose is to reduce the symptoms associated with a variety of allergies. In clinical trials of Clarinex D, 5% of the patients in the study experienced insomnia as a side effect. A random sample of 20 Clarinex D users is obtained, and the number of patients who experienced insomnia is recorded. Now, it's important to note before we even go anywhere that this is a binomial experiment. You have a set n, you're looking at 20. You have a set p, probability of success of 5%. And because these are random patients, whether one person has insomnia has no effect on whether another person has insomnia. So they're independent trials. Great. All right, now we have a lot of questions to answer about this. So I think what will be easiest for us to do is to create a very large distribution just right off the bat. All right, so I'm going to type 0 here because that's the fewest number of people that could suffer from insomnia, right? So out of 20 users, you could have nobody get insomnia. I'm going to click and drag. I'm going to go to cell 23, no, 22. Oh, we'll see. And then it made them all zeros, which I don't really want, but then it has this little autofill thing. So let me click on that, and I'm going to click Fill Series. And then it fills them all with numbers. Look, 0 through 20. Great. Now, let's see, probability equals binom, because we said it's binomial. There it is, binom dist. Now, the number of successes is right here in cell A2, comma, the number of trials was 20. The probability of success was 0.05, although I wouldn't really call insomnia a success, but you have to remember that success doesn't necessarily mean good things. Success means, well, something very statistically speaking. So if 5% are experiencing insomnia, then having insomnia is considered a success. All right, and then false for the cumulative part. We're not really going to work with cumulatives at this point, so just always make them false. And then I grab the handle, I drag it down. There we go. Now notice, just real quick, I want you to notice this. Down here, these are really small. What's going on here? It's not 9.53, of course. You can't have a probability that's 9.53. You can't have a probability that's higher than 1, right? Right? Remember that from Chapter 5? Well, what this is it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? 19, 20, 21, 22, 27 zeros, 9, 5, 3, 6, 7. Of course, we don't really write it like that, but that's what it's really talking about. It's a very, very small probability. This is scientific notation. This capital E negative 11 thing means that there's that many zeros, well, actually one less than that many zeros, right? You move the decimal spot 11 spots to the left, or 13 spots to the left, or 27 spots to the left. So just keep that in mind. All right, with this we have everything we need to answer all the questions. So for part A, it said find the probability exactly 3 experienced insomnia. That is, here's 3 right here, that answer. Done. Part B, find the probability that 3 or fewer. All right, 3 or fewer is all of these ones. So I'm going to add up 0 through 3, including 0 and including 3. That's 0 to 3. Done. Find the probability that between 1 and 4 inclusive. Inclusive means you include it. So find the probabilities between 1 and 4. So I'm going to add them up. Sum 1 through 4, all of those. B3 to B6. Enter. D. Would it be unusual to find 4 or more patients who experienced insomnia effect? So let me find first the probability of 4 or more, just for starters. 4 or more is all of these ones down here, right? Now notice what's not in there. This one that we already found, right? 3 or fewer is right here. We found it. So 4 or more is 1 minus this answer. That's that probability. And notice that probability is less than 0.05. So yes, it's unusual. Done. Smaller than 5% makes it unusual. And we are finished.